Question 2 is on trigonometry, and the key thing to recognize here is that we are dealing with radians. So you need to make sure that your calculator is set up with the angles in radians. So we've got this quadrilateral here. We're told AD equals 7, BC equals 8, and we've got these two angles here. We are asked to find BD in part A, which is this length here. So we should hopefully notice that we've got here an angle and a side opposite, and this length that we want to find, this unknown BD, is opposite this angle here, 1.75. So here we can use the sine rule. So we would say that BD over sine 1.75, which is the angle opposite it, is going to be equal to 7 over sine 0.82, which is the angle opposite it. So we can rearrange that to get that BD is going to equal 7 over sine 0.82 multiplied by sine 1.75, remembering to check that your calculator is in radians, and that gives us an answer of 9.42 centimeters. So this length here is 9.42 centimeters. And we're going to probably need that when it comes to looking at B, which is finding angle DBC, which is this angle here. So, relative to this angle, let's just call it theta, we can see that we've got 1, 2, and now 3 sides. So we've got all 3 sides. We're going to find the angle. So that should ring some bells that we need to use the cosine rule. So you've actually got the formula in the formula booklet. So we can write here cos theta is going to be 8 squared plus 9.42 squared. Remember, if you can on your calculators, use control answer rather than entering in 9.42, because this is going to be a rounded answer. So we've got the two angles, the lengths either side of the angle, 8 squared and 9.42 squared. We're then going to subtract the square of the side opposite, which is 12 squared, and divide that by 2 times these two lengths, 8 and 9.42. And if we do that, we get 0.058. However, we don't want cos theta, we want theta. So we need to, therefore, take inverse cos 0.058. And if we do that, we get an answer of 1.5 radians.